Its surface is heavily pockmarked with craters left by thousands of meteor impacts, but new research suggests something else may also be shaping the Moon's landscape. Physicists say bolts of lightning generated by the static charge built up in the fine dust coating the lunar surface could be melting and vaporizing its soil. This may help to explain the battered appearance of the Moon's surface. The researchers said the electric charges could build up in the lunar soil, also known as regolith, due to the high-energy particles thrown off by the sun in solar storms collecting in cold areas. When enough of these accumulate, they could trigger tiny explosion-like sparks as the charge suddenly channels through the soil. They estimate in dark regions of the Moon, where the charge is likely to build up more due to the cold conditions, 10–25% of the upper layer dust has been blasted in this way. Speaking to New Scientist, Dr. Andrew Jordan, a researcher at the University of New Hampshire in Durham who was lead author of the study, said, "The electric field keeps building up and then snap, you go from nothing to conducting almost instantaneously." The researchers, whose work is published in the journal Icarus, believe it may be possible to look for the remnants of these mini lightning bolts in the Moon's soil. It may even be present in samples of lunar regolith brought back by astronauts on the Apollo missions. They describe this altering of the lunar soil breakdown weathering. But they say they would expect this process to decrease the reflectance of the lunar surface because on Earth lightning strikes can create dark clouds to form on rocks. If something similar was happening on the Moon, it would make the lunar surface darker, not brighter. However, the lack of oxygen and chemical makeup of the regolith may be responsible for the difference. Such electrical discharges could also pose problems for future missions looking to explore the areas close to the South Pole and other regions that remain in permanent shadow as they could interfere with electronic equipment. Writing in the journal, the researchers said, "The Moon's permanently shadowed regions may be more active than previously thought. Although they are not directly exposed to sunlight or the solar wind, they are still subjected to meteoroid impacts as is the rest of the Moon's surface. Also they are exposed to penetrating particle radiation. Regolith within permanently shadowed regions is so cold that its electrical conductivity is extremely low, creating discharging timescales of 2 to 3 weeks. These long timescales may enable large solar energetic particle events to charge the upper 1 mm of regolith to the point of dielectric breakdown. Sufficiently large events are estimated to occur approximately once a year. However, the researchers say experiments and ultimately samples from the Moon itself will only prove if their theories are correct.